Nice to see a few familiar faces here. My name is Shubha. I'll be your facilitator, moderator today. I've been with Sidebar for a little over 2 years, and I'm a fractional chief AI officer at a generative AI startup called Wayfound.ai. We are an agent success, agent management company. Um, I also do AI consulting on the side and teach AI, and I have a Maven course actually coming up on September 15th that Kia was actually part of the last cohort in July. I am so excited to welcome Kia. I think this is the second or third time that I have the privilege of welcoming Kia, and every time I come away with so much learning because he is so generous with his expertise. I'll allow Kia to introduce himself and take it away. Kia, welcome again.
Thanks, Zuru. Yeah, it's my pleasure to be here with all of you. I will share screen so you can see what we're talking about today. Today's talk is about LLMs. If you don't know, LLM stands for Large Language Model. And the goal for today is to go over essentially basic principles so that you can understand how the premier LLMs work. So ChatGPT, Claude, Gemini, these are all LLMs or based on LLMs under the hood. And so we're going to go over how inference technology is evolving, what the heck inference means, and how you can leverage this really useful tool to 10x or even 1000x yourself. Bold claim, but we'll see where we go from here. So I'm Kia, like Suba mentioned. I lead engineering at a pre-seed and seed deep tech VC called 50 Years. What I really love about my role is I get to empower our portfolio of companies to essentially scale their impact with software, with AI, and the adoption of innovative technologies. Before that, I was a TL at Google on core dev, so sort of doing the same thing, but Google internally. And prior to Google, I was a founder and VP of engineering at a startup called Mira. Reach out on LinkedIn. I'm always happy to help you adopt new technologies, understand what's going on in industry. Always excited to learn and grow with you guys. So why are LLMs important? LLMs are the underpinning technology behind the AI revolution, the agentic revolution, all of these buzzwords that we're hearing incessantly on the news. But frankly, we're in the midst of a major transformational wave in our society. It's kind of like the Industrial Revolution or the invention of the internet. Andre Karpathy, who's a famous computer scientist, he used to be the CTO of Tesla. He, a couple months ago, said AI is the new electricity. There's VCs postulating that we're moving from like 100,000 people companies to 10-person companies. I was chatting with one of the partners at our VC who said 0 people companies are about to be a reality. And yeah, it seems like a lot of hype. But frankly, this technology is here, people are using it, and I think it's going to be quite the important player in the fate of society for the next 1, 5, and 10 years, and maybe even business. Well, definitely business. So it's worthwhile to be in the know about how these things work. So I'm going to ask a question to the audience. Who knows what GPT stands for? Yeah, feel free to yell out. Anybody? Anybody? You hear it on the news all the time. No Googling or GPTing. It doesn't mean crickets, which is all that I'm hearing. Oh, someone posted. Green pea tort. How did she know, Suba? Perfect. All right, pop quiz time is over. So GPT, it stands for Generative Pre-trained Transformer. And the generative means it can create stuff, all of my jokes, all of my cousin's grad school essays, the entire code base of my current place of work. No, I'm joking, I write some code. The P is really important, it means pre-trained. So the way that these large language models work is that they ingest all the information they can. They're extremely information hungry, and they generate internal patterns with which they use to make predictions. And so ChatGPT, for example, is trained on something like 13 trillion words. I probably just made up that stat, but some massive number of text information, so like textbooks, Wikipedia, Stack Overflow, probably all the Harry Potter novels in one, anything it can get its hands on. It's ingested that in its training process to develop its internal understanding of the world. And then based on that understanding, it predicts patterns. So you can say, tell me a joke, and it's seen thousands, millions, trillions of jokes, probably millions or billions of jokes, and it can guess like, okay, here's a likely joke. It's a predictor, right? And the transformer is the technology that allows these large language models to predict and understand the relationships between words or tokens. Tokens are segments of words, and that's the like primitive for these large language models. So to summarize, a GPT is a predictor that has seen a ton of stuff and knows how to decide what word should come next. And it uses this internal knowledge to produce a lot more stuff. And so I like really simplistically like to think about it as, remember algebra class way back in school where you're given a line on an X and Y axis and you want to predict given an X, get a Y. That's essentially what these GPTs are doing, or these LLMs are doing in multidimensional space, where you're saying, hey, the word dog, um, what's the likely next word? And so that would, the word dog would be the x-axis, and the next word would be the uh, y-axis. So it could be dog barks, and then that's a new spot on the line. And dog barks is the x-axis, and the y-axis may be dog barks loud, etc. There's some randomness there. It's not as deterministic as a line because these things under the hood are doing kind of like random selection or sampling of data, but that's how you can think about it. So let's see a diagram. So the x-axis is context. And you can think about the slope or how it maps that x-axis as the internal weights and parameters of the model. And what an LLM does is produce an output. So when I say, tell me a joke, the prompt, tell me a joke, plus some other context that's programmed into these LLMs, is mapped against the internal weights and parameters of the LLM to produce whatever funny joke the model produces. And so this is pretty simplistic, but at the end of the day, what LLMs do is take context, map it against their internal weights and parameters, what they were pre-trained to understand, and then produce an output. So really simple example here is, here's Claude. Is this enough? Can you guys read this, or should I make it bigger? Where I say, tell me a funny joke, then Claude gives me a hilarious joke about scientists and atoms. And so based on all of the knowledge that's been trained on, it thinks this is a funny joke and that the characters or tokens that should follow, tell me a funny joke, are why don't scientists trust atoms? Because they make up everything. And so it's predicting word by word what should come next. And it's pretty shocking that it can mimic human behavior, human understanding, when it's really just predicting on a multidimensional line. But a limitation, right? Like if we look at back at this diagram here, LLMs only know things that they've been trained on and whatever context you provide. And so when I ask this base LLM without any augmentation of that context, I say, who's the mayor of San Francisco in 2025? This version of Claude that I'm querying here or prompting was trained up until October 2024. And so it just knows London Breed was the mayor of San Francisco. And that's its knowledge cutoff. And so its internal weights and parameters are up until October 2024. So that ends up being a limitation when I want stuff that the model hasn't been trained on. And one way to address that limitation is to augment this context. And so next pop quiz, who knows what RAG stands for? Anybody? Anybody? No Googling. All right. Well, so like I mentioned, base LLMs can do all sorts of things based on that training that they have, but there is that huge limitation. They only know what they've been trained on and only what's available in their context window. context windows are getting quite large now, so you can cram a lot of stuff in the context window. Like I can paste Harry Potter into a context window of the latest version of Claude Sonnet and then ask it to write me like a follow-up chapter or whatever, like fan fiction or something that you may be interested in. Don't do that. And so but is limited based on that context and is pre-training. So one way to address that is to augment that context. And that gets us to RAG. What RAG stands for is Retrieval Augmented Generation. And so it provides the LLMs a way to update the context, so extend what the LLM is making its prediction based on, so that it can get better, more accurate predictions. So we use this at work. We put in a RAG system like a bunch of our writing. And so when we produce copy for marketing or websites, we run it past our RAG system so that it's more akin or more aligned with our team's writing. And so RAG allows you to customize and personalize how the LLM behaves. Additionally, say there's some private database of all the acronyms that we use at work. There's no way an LLM is pre-trained on that. And so we can add that to a RAG-based system so that it can make predictions that align with what we want. So let's see what this looks like in the diagram, and I'll walk through it slowly. So this one's a little bit more complicated, but imagine I prompted, what is RAG? That goes to, that's first retrieved from our knowledge base. So let's say that's a database that knows a bunch of LLM terms. The knowledge base looks up, hey, what are some things that are similar to this phrasing here? What is RAG? And so that's called semantic search. It looks for things that are semantically similar. Then it takes my original prompt plus that augmentation from the knowledge base to create an enhanced context and an augmented context. And then the LLM takes that augmented context, same thing, right? Takes that context, takes its internal weights and parameters, makes a prediction. And that's how RAG works under the hood. So what can we really do with this? If we go back to our trusty Claude, I've created a project here that has my favorite travel locations. I've said, I love to go skiing in Revelstoke. I love to go skiing in Tahoe. I love to not be skiing in Maui. And I love drinking wine in San Remi. And so this is the knowledge base that this version of Claude has access to in this project. And so when I ask it, where should I go next on a trip? It first looks up the relevant information. So you can see here, the user has uploaded a document containing their favorite travel locations, which include Revelstoke, like Tahoe, Maui, et cetera, that document I provided. And then it tries to give me more, makes a prediction based on its internal maps and that augmented context, right? So if we look back over here, its internal weights and parameters, it may know that Revelstoke is in Canada and that Tahoe is a mountainous region. And so it seems to think that maybe I should provide some mountainous places. Ooh, Maui is a coastal island escape. Maybe I should provide some places like Santorini or Big Sur. And then lastly, I said San Remi, which is a wine region. And so it's like, you should go to Tuscany. But as you can see here, RAG is also limited because it only knows what you provide it. And again, it's weights and parameters. All that we have control over in this system is enhancing that context and then whatever the model has been trained on before. Unfortunately, we don't really have much control over what the model was trained on before. And so when I ask it a follow-up question, what is the weather in Tuscany today? Because I really want to start drinking in Tuscany. Again, the model doesn't have access to weather data, right? Unless I provided that in RAG, which isn't really feasible because weather data is changing by the minute or second. And so it says I have a knowledge cutoff of January 2025 is a different model. And I don't have any real-time information capabilities. But check out weather.com. It was probably trained on these as available sources, but it doesn't have the live dynamic data of these sources. And so because of that limitation, the next kind of evolution is adding dynamicism to LLM-based systems. And the way that's done is with tool calls. And so LLMs with tools, because RAG is static or restricted to whatever is living in your database, tools allow LLMs to dynamically inject things into their context or also to modify their outputs. So for my weather example, we could provide a weather API as a tool to our LLM. And when I ask what's the weather in Tuscany, it can call weather.com or dark skies API and provide the dynamic current weather in Tuscany. Another interesting, I mentioned that LLMs allow you to modify that. Sorry, tools allow LLMs to modify the outputs as well. When you generate a image in ChatGPT or Claude, what that's doing is calling a tool to take whatever textual information or textual prediction it has and transform it into an image-based output. And so that's how some of these models are multimodal. So image, video generation, those can be implemented that way. Um, so the current models today, the most prevalent tool is web search. And so when I go to ChatGPT, it has search enabled, and I will ask it like, who's the president of the United States today? And it will say searching the web for current information. So that searching the web portion is a tool call. Um, and so there are lots of things that you can do with LLMs with tool calls. You can also actually build your own tools using something called the Model Context Protocol. I'll show you guys a quick example here. So here are some of the tools that are just out of the box available to Claude in this case, but ChatGPT has something similar. So it could call Google Calendar as a tool. It could search my Gmail as a tool. It could look at my Google Drive. And then also when I click Manage Connectors, you can actually create your own custom tools. So let's see, here's Winston. It's disabled for this project, but this is a custom tool that I've built for work so that I can access our own APIs privately. And so this is really useful. It extends the capabilities of this prediction machine by giving it the relevant context it needs, the dynamic context it needs. So back to our chat. Here is a simple example where sure. Let's just show the diagram instead. This is easier to think about. So actually, this is kind of a messy diagram, but bear with me. So if I ask an LLM, search for information about quantum computing, what the LLM does first is it analyzes my prompt and checks what tools it has available and decides what tool to use. And so in this case, this LLM example has a web search tool, it has a knowledge base, it has the ability to run code and to do calculations, like math-based calculations. And so it selects web search is the likely tool. It searches the web for information about quantum computing, and then takes those results, augments the context of the LLM brain, and then makes that final prediction. And it provides, based on that new context, everything it knows on quantum computing. I know this is a lot to take in, so I'm going to leave the slide here. And then, Suba, are there any questions related to this that I can help
Yeah,
answer?
there are actually a couple of questions that
Mhm.
came in over the last few minutes. Kim, do you want to ask your question regarding the difference between Markdown files and RAG?
That's my question.
Yeah. So yeah, Markdown files can be provided as an input to RAG. Typically in a RAG-based system, what it does is it encodes the Markdown, and then it can look. It's called embedding. It embeds the Markdown, and then it can do semantic similarity searches. So say your Markdown has a bunch of dad jokes. If I prompt it for dad jokes, it's going to look for something that's similarly labeled. And so Markdown can be a source provided to a RAG system and can be retrieved using semantic similarity search. So this example here, this is just a Markdown file as a source for RAG, but when at inference time or at the prediction time, it's looking for, I probably said recommend somewhere to travel, and it's like, oh, there's this document here about travel. Let me pull this into the context. And so that semantic similarity is how RAG works and decides what to provide to the context.
So can I get a follow-up question?
Yeah.
So if I'm understanding and digesting what you're saying, essentially, in order to create an even more hyper-personalized LLM for me as a reflection of me
Mhm.
as like a person,
Yep.
it could be beneficial to create the markdown files, store the information that I want specifically as a reflection of like me, and then use the
Mhm.
RAG in order to be able to create just an even more hyper-personalized like LLM response.
Yep. Yep. If
Okay.
you've used any of those like digital clone platforms, the way they work, one of the ways they work is you just provide them with a ton of information about you, examples of your writing, the way that you've talked about things in the past, and they use RAG to augment the context. Obviously, they're more complicated and some of them are, we'll talk about a little bit later, but that's how a lot of these systems initially were created. So the first iteration of LennyBot, for example, was just RAG on everything that he's written before. And so when you asked what are the top recommendations for product-led growth, it probably found transcripts from his chats with PLG experts and then provided those. So that's what it pulled into the context. That's what it retrieved. Cool. So tools a little complicated. The important thing here is the LLM is provided with a whole registry of tools, right? So if we look back at Claude over here, right, these are the tools that Claude has access to. And when I send a query, like look up my birthday in Notion, it evaluates that prompt, says, oh, I should probably use my Notion tool, modifies its context, makes prediction. And so here, the example, it searches the web, modifies its context, and then this arrow is kind of hard to see, but then it generates a prediction based on that modified context with the dynamic tool. So let's move on. So the next evolution of tools and LLMs is the buzzword of the year or of the summer, agents. So agents are LLMs that are in a loop essentially, and that loop is structured so that they can reason and observe and decide what they want to do next. So agents typically follow this React pattern where they have a thought that triggers a action, then they observe the results of those actions, and then they may have another thought or they may return the results to the user. So a simple example is imagine an agent is looking for a toy in a bedroom, right? Imagine I had a agent for my son to discover toys. That'd be great. Otherwise, I have to find it, right? And so the agent may think, I need to find my toy. Maybe I'll use my tool to look under the bed. And so it will look under the bed. The result of that check may be, oh, there's no tool, there's no toy under the bed. Maybe I'll use another tool to look in the closet. And they'll look in the closet, like, oh, toys in the closet. It will return to me, toys in the closet. Another example is this one here. I need to check the weather in Paris. Let me see if I have a tool to search for that information. It will search the web and decide like it will rain today. And then it will say like, oh, okay, since it's raining, I might need to bring an umbrella and provide that information to the user. So most of the LLMs that you interact with today are agentic by default. So one of the examples I showed you earlier, this example where I said new travel recommendation. So this thought process up here actually is an agentic thought process where it's saying, it's thinking the user has uploaded a document. So I have this tool available. Let me read this. And then let me look. I have another tool to read relevant chats. Let me look at those relevant chats. And then I'll make that prediction. Now that I have all of the information available to me. Another example is whenever you use research mode or pretty much extended thinking, you may see here, ChatGPT has this as well, where it's doing multiple tasks and you see those little thought bubbles. Those are agentic loops happening. And so let's see what that looks like actually in action. It's again a little complicated, but it's essentially wrapping around the core LLM's prediction ability to make more intelligent decisions and actually to loop and make multiple decisions. So I may ask an LLM or an agentic system, please book a flight to Paris for me. And so the first thing that it does is it decomposes the request, and then it might look for the tools available to me. And so in this case, there's a flight API, there's a database, there's the ability to search the web. And so it may decide, okay, I'm going to call the flight API, and then it will get a bunch of flight information back. Update its memory, which is a new addition to agentic systems. And then this context will be used to make a prediction about what should I do next. I have all these flight informations. Maybe I should book or decide like how much it will cost to take a bunch of flights from wherever I am to Paris. And then it will continue to have these observations until it thinks it has enough information to make a final decision and say like, hey, go take these flights to Paris. It will cost us much money. Um, Otherwise, it will just keep looping until it thinks it has enough information. It will loop back and do this planning, thinking, predicting until it feels confident. So let's actually see what that looks like. So in N8N, I've made a pretty simple, it doesn't look that simple. I've made a pretty simple agent system here. And I say that help me plan a trip to Maui is the input I provided. And so that's passed to the agent. And all that it gets is help me plan a trip to Maui. And that goes straight to an LLM. And so the LLM internally looks in its memory. So it loads, this is really difficult to read. So let me make this a little smaller. The LLM loads a bunch of memory, says, okay, this is the first conversation. And then it goes to OpenAI with this prompt. This is the context in action right here. Your helpful assistant that looks up flights for a specific location. The human wants to find a trip to Maui, and you have access to two tools, a calendar tool and a web search tool. Surf API is just a web search. And so this system or this context wants to find the cheapest flights within a 3-month period. And so the next thing it does is it looks into my calendar and tries to find events on my calendar, calling its calendar tool in the next 3 months. So it has, looks like my birthday information and my aunt's birthday. And so it gets all of those things back. It provides us with context. And so here in OpenAI, this updated context is used to do a new prediction, right? So it says, input, help me plan a trip to Maui. You have access to these tools. Oh, and by the way, here are Kia's calendar invites. And so based on this, it's going to make a prediction. It's like, okay, I know what Kia's availability is. The next thing I should do is search the web. And so here it looks based on those dates, cheapest flights from San Francisco to Maui from August 26th to August 30th, because it thinks that's when I'm available. And it gets back a bunch of flights. And so you can see here's that new prediction. Help me plan a trip to Maui, right? It has all of this memory from its previous loops, has my flight information. And then additionally, if we scroll all the way down here, and again, this is made for LLMs, not really for humans. It's a massive prompt that it's producing. You can see here at the way bottom, it has some flight information. So you can see here, start at Los Angeles, go to Europe, it looks like. This is some flight information it got from the web. And so with all of that, the LLM's able to make a final prediction. It said, here's what I found, 2 multi-day windows in your calendar over the next 3 months with all day or evening conflicts, with no all day or evening conflicts, plus the round trip information. So you can do a late August getaway, and I can go Alaska Airlines to OGG. I should probably know where that is, and then I return. I guess OGG might be Paris. Sorry, Maui. And then here's another option based on my availability. And so we can actually see this live, which might be helpful. So I can ask another query like, help me plan a trip to, let's say, Paris. And so you're actually seeing first it writes to its memory, then the LLM, or maybe it's slowly writing to its memory. What is happening? Live demos, the bane of my existence. Yeah, let's reset this whole chat session. Oh. I'm going to refresh this page. There you go. There's a critical update. So I'm going to ask it to help me plan a trip to Paris. And so the first thing it did was look at its memory. Now it's making a prediction. This prediction is, again, all that context. That prediction made it think, oh, I should look in my Google Calendar. Then it's making another prediction with the Google Calendar. And it's probably going to decide, okay, I know what the availability is. Let me look on the web. And so that's what it's doing now. And then I have all that information. I'm going to provide the final answer. And so it thinks I should go to Paris. We'll see in a second. Nope, it's still doing some other loops based on other search results. And here we are. Oh, another search. Looks like my calendar is very busy. But you can see here it's calling the web based on these dates to Charles de Gaulle. Then it's doing another date. Wow, it's looking for another date here, September, and one more date next week. And so hopefully after all of these searches, it will feel confident that it can provide a safe guess. And so here it's doing its final prediction, hopefully. We will see. Oh my gosh, my calendar might be kind of busy. And going back to a different time in October. Come on, Mr. Agent. Here's another search. It seems like it has a lot of information, so hopefully you'll be able to plan, output something. Oh, no, maybe it's stuck in a loop. So it might be agentically going back and forth. Maybe my calendar is quite crazy because I'm taking paternity leave for the next few months, and it's just like, we have nothing in the next 3 months for you to take. Maybe I've set this agent up for failure, but that's how these agentic systems work under the hood. Oh, it did. It decided, okay, based on your calendar, October 8th through October 13th, you have no all-day events or blocking appointments. Actually, I don't know if that's true. Uh, and so here are some options that you can do. And then it says, here are the next steps. So again, this is how these agentic systems work, right? They have memory of what they've searched, of what you've provided. They're augmenting context, making a prediction. Then they're calling to tools if they have them available, augmenting context, making a prediction. And that cycle goes and goes and goes. And the agent's able to reason and until it thinks it has a good enough answer. And so that's how this is working. And it's just this loop that you just saw over and over and over until it comes to a final result. So imagine you had a team of these agents working together, right? You could have whole AI teams. You may have a manager agent that can decide what tasks are available. And that manager agent may shop them out to other sub-agents. So there might be a research agent that looks at some market information. There could be an analysis agent that takes that market information and makes some predictions. And then once all of that information is available back to the manager agent, so it might say like, hey, here's all the information we have. Here's the analysis. Here's the research. Content expert agent, can you produce some marketing copy or a LinkedIn post for me? And so you can think about A2A, which is the protocol with which these multi-agent systems work, as that kind of like Slack for robots. It's just the way that they talk to each other. And so there are a bunch of examples of this, but AutoGPT, Crew AI, Open Agents are these A2A systems. And what's quite cool about them is they mirror the analogy of the human brain, right? Whereas like each of these sub-agents may be a specialized intelligence, and aggregated together as a swarm or as a system, they may mimic or act similar to a general intelligence. Another cool analogy is I work at a VC, and so you can imagine I might try and replicate sub-agents for each of my coworkers, where there might be an Alex bot who evaluates the technology of the company and the economics. There may be a Seth bot who assesses the founder's stories and their potential, how intense they are. There might be a Kia bot that analyzes technical excellence and market vision. And then there could be an Ella bot that judges how well the team communicates and what their founder dynamics are like. And then all these bots can work in concert to make a decision to provide capital or not. And so this is how these multi-agent systems work, essentially. Each agent is specialized, does something specific, and then there's either like a manager agent or an overseer agent that makes the final decision based on each of those individual agents. So holy moly, if these multi-agent systems and these models are getting this good, like why would I even why would I even bother to make a company? And I just wanted to say, like, I think about these technologies as amplifiers on your existing skills, not replacements. So as you all saw, like the agent can kind of get 90% of the way there with the tools available. So like someone with no travel advising expertise could like sort of give you useful bookings, but it's really only getting halfway of the way there. And so it probably takes an actual human to take it from that 90% to 100%. A lot of like the vibe coded prototypes you may have seen work really great for a demo, but typically you need an engineer or someone like that to take that prototype and make it production ready or make it scale. On the flip side of that coin, experts that are already using these tools and leveraging these tools are one, really well equipped to evaluate the output of the tool. And then two, they can chop out the menial tasks that they don't want to do to these agents or these tools, and then effectively add a force multiplier on their time. And so looking at it through this lens, I think fundamentally AI and these tools will be a really stratifying technology, meaning that um, as an individual, the cost of doing menial kind of basic tasks, it's moving towards zero, right? It's getting easier and easier to get like an average or like the median output for some skill. And the cost of like generic analysis or expertise is going also to zero. But where's really exciting is taking what you're already an expert at and multiplying it with these tools, leveraging these tools to highlight your expertise, to distribute your expertise in um, larger circles. And really, I think you don't have to worry about AI replacing you. Under the hood, though, what could replace you is an expert that is really well versed in AI and able to multiply themselves with these tools. And so the winning strategy isn't to avoid it, but master usage of these tools, understand underlying technology so that you can amplify the unique expertise and market insights you have to win that market, to move faster. So the goal should be focus on how you can combine your irreplaceable human perspective with these tools, because underneath they're not intelligences, they're not consciousness, they're just tools, and use them to make something truly transformational. And that's my slide. I'd love to answer any questions that you might have. And as I said that, Suba is off. So Gary, I think you have the first question. Do you want to just answer in chat and post it? Yeah.
Yeah. So it's here somewhere. Yeah, so as I understand it, so I can upload like reference pieces like articles or books or whatever that talks about a very detailed and a specific project, and maybe even has the slant that I would like to use, as
Yeah.
opposed to the other side. So if you upload that to like to a project and you tell it, just use it for this project, and you're doing another project, and you tell it not to look at that one, look at this book instead, type of
Yeah,
thing.
projects are specific to projects. So if you create a new project, it will only take the information that you've provided and any like system level information you've provided. So a cool example of this is I have a digital clone project that has a bunch of stuff about me. So like really
Okay.
basic facts like I live in SF, I have a sister, my wife and I have a dog two dogs and a cat. And so this information is provided in like a RAG context a to an LLM, and then it makes predictions or it acts in my behalf based on this and many other documents. And so you can essentially upload all of this stuff into a context or into a project, and that project can act aligned with the documents or semantic information that you've provided it.
Then can you
So
tell it not to share it with other projects, for example?
yeah, projects
Okay.
are scoped. It depends on the system that you're using, but in most cases, projects are scoped. Claude is a good example of this. There's no project bleeding, stuff like that.
Okay. Okay.
Yeah.
And my other question there was, friend was showing me about Replit.
Mhm.
which he's like revolutionized, makes him walk on water. I mean, it's like life changing for him and his business.
Sure. Yeah.
So is that kind of just a tool to help you build agents?
Yeah, so Replit has an agent that helps you build software, also helps you build agents, and it also will deploy software to you. So it's a agentic way to spin up other agents, kind of meta or software. And so people build applications on Replit, they build APIs on Replit, they build um, full software suites on Replit. It's quite the cool product.
Yeah. Okay. So it's worth investing time to learn.
Yeah, for sure.
Yeah. Okay. Thank you.
What else? Who is next? Latha?
Oh, yeah.
Lata? Hopefully I'm
Lata has
pronouncing your
just
name
stepped
correctly.
out. So,
Okay.
Elizabeth, you had a question?
Yeah. Can you guys hear me okay?
Yeah.
Mhm.
Sweet. So Kia, when you were talking about tools, I was just curious. I use ChatGPT more than Claude, and
Yeah.
just curious about like building a custom GPT versus, building a tool that you integrate. What the difference
Yeah.
would be between those two.
So custom GPTs are just wrappers around tools. It's kind of a restricting. Can you guys see ChatGPT on my screen? And so when you build a custom GPT, um, it really is, you're just saying, hey, here are the capabilities or tools that you have, and you can also provide other actions here, which call other tools. So yeah, what's happening underneath the hood here is this custom GPT is doing tool calls, or it has access to the tools that you provide it. But it is just doing tool calls. Hopefully that answered your question.
Yeah, I think it did. I think maybe more specifically. So if I wanted to create something that's going to allow me to minimize the amount of drafting time, if I wanted to write YouTube scripts, right? I write a
Yeah.
lot of the LinkedIn posts and a lot of Instagram posts, and I want something that I'm going to be able to do like a voice note where this is the concept, this is the idea, but this is the framework that I would like you to follow in order to create like an 8-minute YouTube script. Are you thinking, custom ChatGPT or another way to go about doing that?
Yeah, you can do it either way. Custom GPTs work great for that. So here's an example from work where I've provided basic instructions. You can't really see this here, but there's a ton of knowledge documents that we've also provided. I don't know where that is in this UI anymore. They changed it. But we've provided a bunch of like writing examples. And so people on my team use this to produce copy in a way aligned with our brand. You can do the same thing for transcripts.
Awesome. Thank you.
Just to
Yeah.
add some color to Kia, what you mentioned for Elizabeth's question, my understanding is that custom GPTs don't have the kind of memory that is needed for continuous iteration and improvement, right? So for Elizabeth, the first time she wants to create the 8-minute script, to your point, custom GPTs are great. But for the 10th time, if she wants to create it with an elevated level of like personal brand and voice, it just doesn't have that kind of context and memory, because to your point, it is that wrapper. Is that correct? Or
Yeah, so a Claude project where it references previous chats might be
Yeah,
better if
better.
you're going to be. I guess there's two ways you can improve the predictions, right? You can continuously modify the knowledge document that you provide to the custom GPT, knowledge documents that you provide to the GPT. So you can say, like, here's some examples of good transcripts. Here are some examples of bad transcripts. And you can continue to augment the custom GPT that way. But now that so Claude ship memories and projects, GPT also has memory where it like learns your preferences and stuff. I don't know if there's memories in custom GPTs. So Claude project might be a good way to do it. Probably a simpler way.
Yeah.
Thank you.
Or projects in OpenAI, like ChatGPT itself, they have that feature too.
Yep.
That probably, thank you so much. That makes sense, because I think with just like the normal, whenever I create a script, like that seems to work really, really well. But whenever I go to this custom ChatGPT, I'm like, it's always falling short. Last question. Do you guys know anything about Poppy AI? And well, I guess I'll stop it. Okay.
What
Thank
does
you.
it do? Yeah, I may know an analog.
So I think my understanding is it's almost like this sense, it reminds me almost like a Figma board where you can drop in, you can create this like container, and you can put certain elements from the web, whether it's YouTube videos or whatever, and it will focus on that content. And then you can almost drag it into a new container. And it's just like building, I think, a brain specifically for what it is that you want. And I'm probably using the wrong terminology, but that is what I took away from it. So I was considering using that to continue to build YouTube best practices, right? There are people that I follow. So how can I take these videos and have it use the transcripts to create this? And then how can I take all of the content that I've created previously? So yeah, just wanted to know if you guys had any context on that, but I will continue to look into that. So thank you.
Sounds cool. Let us know what you discovered.
Kia, on the topic of like just so many options and so many tools, Anita has a relevant question. Maybe we could just ask that. Anita, do you want to ask the question quickly?
Yeah, thank you. So I have been exploring and trying to do some POCs. I've been playing with Claude and ChatGPT, both paid versions, free versions, and then we have Replit, we have Cursor. There's so many out there. For somebody to just start simple to build out an app for my own personal use, like I want to create just like what you were showing, my calendar and appointments and build my writing schedules and things like that. um, you know the free versions are only so many credits you get on a day. It doesn't go well. And for a beginner, they they're okay investing, but where should they start and what's the right approach to look at it, and how can they quickly ramp up and build out? I think there's always this initial thing that is not very clear where to start because there's so much out there. And then once you start paying, you don't know how many times you are swiping.
Yeah, for sure. So I guess I have two pieces of advice. One is there are like wrapper tools or specific tools for every use case. And so like Replit and Cursor and this Windsurf, and I guess Windsurf doesn't exist anymore, but like they're a Bolt, Lovable, like they all sort of do the same thing. And so if you have a very clear use case in mind, I'd say just pick one. They're all like get you to the Pareto frontier, meaning like they'll all get you like 80 to 90% of the way there for like a quick prototype or something like that. And the marginal differences you may get by like choosing Replit over Lovable or Bolt is pretty negligible. So I wouldn't pay for all of them. For most bang for your buck from like a general tool, I would pick one of the premier offerings. So like ChatGPT, like Plus or Pro, whatever the like $25 one is, and or Claude, the $20 one, or Gemini, the $20 one. Like those are all pretty comparable, and they're all leapfrogging each other in functionality. Under the hood, they're just orchestrations around LLMs, and the LLMs are getting more and more powerful over time. And so, if you were to pick one of these premier models, I'd just pick one of those big three.
Thank you.
Yeah, did you have more or can we go to more questions?
Yeah, questions. That's all the blabbering I have.
Oh, no, not at all. Anita, you had a follow-up based on the memory conversation that Elizabeth and Kia had. You want to come forward and ask that?
Like I said, I have tried both the free versions and the paid versions with Claude and ChatGPT. One of the things, I'm trying to train my own content that I can use, and my experiences so that it can be more effective. I've seen memory limitations with the free version, but definitely I've not seen the memory limitations once I started to pay. That's what I saw, but I don't know if that's true. Once you pay, there is no limitations. But if you are using a free version, there is a restriction on how much you can put it in the context.
Yeah, so just want to clarify two things there. One, when we talk about memory, we're talking about the internal knowledge base that the GPT builds through its, or the LLM builds through its interactions with you. So that's different from context or context window size. So cheaper or free tier LLMs have smaller context windows. So there's a limitation to the amount of stuff you can paste into your prompt, for example. So if you pay more, the larger models, more powerful models have larger context windows, so you can paste more stuff into there. And it looks like Elizabeth may believe differently, but And maybe there are memory limitations for these models as well. Let's find out. Let me look at my customized ChatGPT and see what's in my memory. It looks like here, let's share. But yeah, maybe paying for more. This is the top one. It looks like manage memories is an option. It looks like I haven't, oh, this is not even the right one. Let's see if there are memory limitations on this one. Oh, it looks like, oh, I have memory off for this one because it's corp data. Yeah, so maybe there are memory limitations. That's something I'd look into based on the model that you're using. But typically when you pay more, you'll have more memory. Most importantly, though, what you're describing sounds more like a context issue where you're not able to paste as much content into the chat. And so, yeah, cheaper models or free tier models have smaller context windows. So that something to keep in mind.
There are some tool suggestions coming up. Chris is recommending Replit as his personal preference. I love it when we always have tool preferences. I wish we had like a voting thing. I'm sure we're all, we would all love that. Julia had a question about personalized memory. Julia, you want to ask the question live?
On my personalized memory. So like I've posted my resume, I've posted different things about the business I'm consulting for and things like that. And I start a new chat because I want to, do something else. It tends to forget, like, no, remember, this is the business name, or remember, this is what's on my resume. And is that a memory issue too? Or, but because I thought they had fixed it so that it remembers all of your previous chats and everything else.
So so you can think about LLMs as like autoregressive by default. So like the girl in 50 First Dates, every interaction you're having with them is a brand new interaction. Some providers are giving the option to persist memories or context. And so that's something you have to turn on typically for your account. I think GPT-5, they have it on by default. But those memories are small kind of core segments. So it won't remember all the nuances of your previous chats. So the ways that you can augment that context, or you can think about like putting up sticky notes, like in Memento, or walking them through. So the ways you can do that are projects, RAG. And so in ChatGPT specifically, projects are a great way. I'll show you. This is probably better. Can you guys see ChatGPT? So here's an example of a project. My secret shared project. Here, let me switch accounts so you can see. Well, no, Zoom is getting in my way. But each of these projects has, it can reference previous chats, and then I can also provide files. And so if you have something that you want to reference your resume or your business plan, I'd say use a project like this. And that way you can persist the important things that you want the LLM, which forgets every new chat. You want it to reference things, doing that in a project's probably best bet. Claude, GPT, they all have projects.
Okay. All right. Thank you.
Yep.
And Lata, you had a question. Read the last question, then we wrap up.
Curious because I use Claude a lot more than ChatGPT, and ChatGPT has memory for to understand me better and gives me better answers. But in Claude, I was wondering if I can cheat using tools and RAG to provide the memory across different sessions.
Yeah. So that's the same thing. Here, I'll show you the analog in Claude, where here Claude has projects. And so projects can have, this one probably isn't that relevant. I have a bunch of stuff split across personal Claude and team prod. But again, so here you can have custom instructions for this project. It will reference previous chats. And then you can add documentation. It's the same thing.
Yeah. Okay.
Here, Claude did just launch memories, I think, this week. And so there'd be some passive personalization as well. I don't know if it's on the enterprise plan or not, but everyone's planning to launch memories as far as I can tell.
Thank you.
Yeah. Thanks, everybody. I actually have to run, but it was a pleasure chatting with you, and reach out on LinkedIn if there's anything I can do to help or you want to explore these topics more.
Thank you so much, Kia, for your expertise as always. And thank you all for coming.